Hi, everybody, and welcome back to day 3 of your descriptive statistics, part 2. All right, for today's lesson, you're going to be needing a writing utensil and a calculator. We haven't used a calculator in a couple days, but you're definitely going to need it today. All right, for today's lesson, our goal for today, given a set of bivariate data on a scatter plot, you will be able to, number 1, write the equation of the line of best fit, and number 2, use the line of best fit to predict future values. All right, let's go ahead and take a look at how we can achieve these goals. Well, let's first define what a line of best fit is. A line of best fit, a line on a graph which shows the direction of a group of points plotted on a scatter plot. This can be used to make predictions for other values. All right, so if we take a look here, in order to draw a line of best fit, there has to be a correlation for the data, and it has to be a linear correlation. So if we look at our first graph, if I look at the pattern of the points, does it look like there is a pattern that forms a linear? Well, yes, it looks like this is going to have a negative linear correlation. All right, so let's go ahead, let's estimate to our best capabilities the line of best fit. So if I take a look here, when I draw my line of best fit, I want to have approximately half the points above the line and half the points below. So I'm going to draw it right here. All right, now let's take a look at our second scatter plot. The first thing we have to do is make sure that there is a correlation. So if I look at the points, do they follow a linear pattern? It looks like they do, and it looks like it's going to be a positive linear correlation. All right, so let's do our best to draw a line of best fit. All right, so I'm going to go right about here, and I'm going to draw my line. Now, if we go to our third, let's take a look. Do the points follow a pattern? Well, yes, they do, and it looks like it is going to be a positive linear correlation. So my slope of my line of best fit will be positive. All right, so I'm going to approximate it right here. Okay, now everybody, here's what I'd like you to do. Take a look at your line of best fit and take a look at my lines of best fit. Are they all exactly the same? Or are each of our lines going to be slightly different depending on where we put the ruler? Well, they're all going to be slightly different. All right, so this year in mathematics, instead of just guessing where our line of best fit is going to be located, we're going to actually calculate a very good, a perfect linear regression, or a line of best fit can also be known as a linear regression. Okay, this is a technique for finding the slope and the y-intercept for a line of best fit. And this is going to be the best line of best fit. So it is the best line of best fit. So instead of calling it a line of best fit, now that we're in algebra, instead we're going to call it a linear regression. You might also in future years hear it called the least squares regression line. All right, but for right now, we're just going to call it the linear regression or the line of best fit. All right, now we have already done this during the school year, but just as a reminder, your steps for calculating the linear regression, you're going to take your calculator. You have to first turn it on. You're going to go to your stat. You're going to go to your edit. You hit enter. You enter your x's in L1. You enter your y values in L2. So stat, edit, x in L1, y in L2. Then you're going to go to stat. You have to use your over arrow to go to calculate. And then we look for the word linear regression, which is right here at choice 4. You then go down to calculate and you hit enter and it gives you your linear regression line. All right, so let's go ahead and let's practice using a linear regression. All right, so here's our first example. Kendra likes to watch crime scene investigation shows on television. She watched a show where investigators used a shoe print to help identify a suspect in a case. She questions how possible is it to predict someone's height? How to predict someone's height is from a shoe print. To investigate, she collected data on shoe length in inches and height in inches from 10 adult men. Her data appears in the table in the scatter plot below. So we have our x's as our independent x. We have our y as our height, which is our dependent. So shoe length and height. So let's look at the data. Does there appear to be a pattern? Yeah, it seems like as the shoe length increases, the height increases, so our line of best fit would go somewhere in this zone. All right, but we don't want to guess anymore about our line of best fit. We want to find the best line of fit. So let's go ahead and answer our questions. Part A, is there a relationship between shoe length and height? Is it a correlation or a causation? Well, let's think about that for a minute. So we already said, well, it does appear that there is a line of best fit, so we're going to say yes. It appears that there is a positive linear correlation. Now, is this a causation? Does having a longer shoe size cause you to have a taller height? Well, some might argue yes, some might argue no, but I would probably say yes. Okay, if your shoe length is longer, your height is probably going to be longer. At least that's what they're trying to figure out in this case. So part B, how would you describe the relationship? Do men with longer shoe lengths tend to be taller? I would say again, yes. It's a positive linear correlation. So now part C, using your calculator, find the equation of the line of best fit, your linear regression line. Round your values to the nearest hundredth. So now we're going to find the best line of best fit. All right, so let's go ahead. We're going to go to Stat. We go to choice 1, which is Edit. All right, in L1, you're going to put in all your shoe lengths. In L2, you're going to put in all your heights. I already have mine in the calculator, so go ahead and hit pause and then plug those in. All right, so now let's go ahead and calculate our linear regression line. So now we hit Stat, Calculate. I go down to choice 4, and I hit Enter. Go down to Calculate, and here we go. So here we have, I'll put this off to the side. So y equals, now we have to round to the nearest hundredth. So here my A value is going to be 3.657, so 3.66. My B value is going to be 25.2. Now that's a 7, but the number behind it is a 6, so I'm going to round up to 8. So we're going to have 3.66x plus 25.28. And that is the best line of fit, which we like to call the linear regression line. So now we're going to use this line to predict some other results. So let's go ahead. Using your equation, what is the men's height who has a shoe length of 12 inches? Okay, so what is the man's height? So remember, height, if we go back up, height is your y. So we're trying to find the y who has a shoe length of 12 inches. So shoe length is our x. So this is going to be our x variable. Okay, so let's go ahead. We're going to use our equation right here. So y equals 3.66x plus 25.28. Okay, so what we're going to do is we're going to input, they give us the x, so we're going to put the x into our equation. So y equals 3.66. Now I'm going to input the 12 for my x, and then plus 25.28. Now I can let the calculator do this for me. So y is equal to, so now in the calculator, I'm going to go ahead and 3.66 times 12, and we get 43.92 plus 25.28. So now I'm going to take that number, 43.92 plus 25.28, and I hit enter, and y is equal to 69.2, and our units are inches, and that's how tall the person would be. All right, so let's go ahead now and let's try part E. Using your equation, if the man's height is 63 inches, what would his shoe size be? So let's review. So the men's height, this is our y variable. What would the shoe size be? This is our x. So let's start by first writing down our equation. Y equals 3.66x plus 25.28. Now we're going to input the variable that we know the measurement of, and that's going to be our y. So under the y, we're going to go and we're going to put in 63 equals 3.66x plus 25.28. Now we have to solve for x. That's what we're trying to find. So to solve for x, we're going to subtract the 25.28. So that's going to cancel. 63 minus 25.28, and we get 37.72 equals 3.66x. So now we're going to divide by 3.66. So 37.72 divided by 3.66. Okay, and it says round to the nearest tenth. So x is equal to 10.3 inches. All right, ladies and gentlemen, our goal for today, given a set of bivariate data, you will be able to write the equation of the line of best fit. We learned today that's also the linear regression line, and use this line to predict future values. All right, nice job. I will see you all in class tomorrow.